Hello everybody, welcome to my YouTube channel. My name is Amrita. Today I'm here with a new video to discuss about corrosion and its types. And I request you all to stay along with me till the end. Without wasting much time, let's get started. So what is corrosion? The process of conversion of a metal into an undesirable compound on exposure to atmospheric conditions, that is moisture and air, is called corrosion. It is also called weeping of metals. Here are a few examples with respect to corrosion. As you can see in the very first picture, there is a nail. When that is being exposed to oxygen and water, it gets corroded, and this process is called rusting. And I'm very sure these are few common examples that everybody would have noticed in their day-to-day life basis. Basic types of corrosion. There are two basic types of corrosion. First one, dry or chemical corrosion. This occurs in absence of moisture. Second, wet or electrochemical corrosion. This corrosion occurs in presence of a conducting medium. Let's learn more detail about them. Dry corrosion. It involves direct attack of chemicals on the metal surface. The process is slow. Corrosion products are produced at the site of corrosion. The process of corrosion is uniform. Example, formation of AgCl on silver metal. Wet or electrochemical corrosion. It involves formation of electrochemical cells. It is a rapid process. Corrosion occurs at anode. The rust is deposited at the cathode. It depends on the size of anodic part of the metal. Example, rusting of iron. Electrochemical theory of corrosion. So here we have got a theory with respect to corrosion, and here we are taking iron as an example. According to electrochemical theory, when a metal such as iron is exposed to corrosive environment, following changes occurs. So let's see what are those changes that is going to take place. A large number of tiny galvanic cells with anodic and cathodic regions are formed. At the anodic region, oxidation reaction takes place, and the metal gets converted into its ions, liberating electrons. Consequently, metal undergoes corrosion at the anodic region. At the cathodic region, reduction reaction takes place. Since the metal cannot be reduced further, metal atoms at the cathodic region are unaffected by the cathodic reactions. Now let's see what happens at anode and cathode and their reactions. At anode, oxidation takes place, in which the metal atoms are converted into their ions, liberating electrons. As you can see in the equation, an iron atom is converted into an Fe2 plus ion, and that is liberating 2 electrons. At cathode, the cathodic reaction is based on the nature of the environment. In the absence of oxygen, there is liberation of hydrogen. It has got two conditions. The very first one, in acidic medium, there is liberation of hydrogen that takes place. Second, in neutral or alkaline medium, hydroxide ions are formed with simultaneous liberation of hydrogen. In presence of oxygen, there is absorption of oxygen. Again, it has got two conditions. First one, in acidic medium, absorption of oxygen takes place. Second, in neutral or alkaline medium, hydroxide ions are formed. The iron ion, that is Fe2 plus, formed at anode, combined with hydroxyl ion from cathode to form a hydroxide on the surface between the anode and the cathode areas. Now, the byproduct of that reaction, that is the iron hydroxide, that further reacts with oxygen and water, forming hydrated iron oxide, which is the corrosion product, that is rust. So here you can see in the equation, rust has got a formula Fe2O3.3H2O, and this is an unhydrated form. Now let's learn about types of corrosion. So the different types of corrosion. First one, differential metal corrosion or galvanic corrosion. Second, differential aeration corrosion. Now this is again further subdivided into two subcategories, that is waterline corrosion and pitting corrosion. Differential metal corrosion. Differential metal corrosion occurs when two dissimilar metals are in contact with one another and exposed to a corrosive conducting medium. The metal with the lower electrode potential acts as anode, undergoes oxidation and gets corroded, and the other metal with higher electrode potential acts as cathode, undergoes reduction and is protected from corrosion. This type of corrosion is known as galvanic corrosion or differential metal corrosion. So you can refer the diagram that is below. Also an important note, the rate of corrosion depends mainly on the difference in potential between two metals. Higher the difference, faster is the rate of corrosion. Differential aeration corrosion. When a metal is exposed to different concentration of air or oxygen, part of the metal exposed to lower concentration of oxygen becomes anodic and undergoes corrosion, whereas the other part of the metal exposed to higher concentration of oxygen becomes cathodic and remains unaffected. This type of corrosion is called differential aeration corrosion, as you can see in the diagram. A few common examples are, part of the nail inside the wall undergoes corrosion. When a dust particle sits on a metal bar, the part under the dust undergoes corrosion. Partially filled iron tank undergoes corrosion inside water. Waterline corrosion. It is observed in steel or iron water tanks partially filled with water. When a steel tank is partially filled with water for a long time, the inner portion of the tank below the water line is exposed only to dissolved oxygen, whereas the portion above the water line is exposed to more oxygen. Thus, the portion below the water line acts as anode and undergoes corrosion. The upper portion acts as cathode and is unaffected. A distinct brown line is formed just below the water line due to the deposition of rust. So in these two pictures, it is very easily visible. You can easily distinguish that a thin brown line is being formed at the surface of these metals. Pitting corrosion. Pitting corrosion results when the portion of the metal covered by dust, which is less aerated, becomes anodic and undergoes corrosion and form pit. The remaining area of the metal, which is exposed to higher concentration of oxygen, becomes cathodic and remains unaffected. Once a small pit is formed, the rate of corrosion increases because formation of small anodic area is formed and corrode faster because accepting electrons from the cathodic area increases. And in the diagram, you can notice the pit being formed. So that's it from my side for today. Thank you so much. In case if you're new to my channel, if you enjoyed the video, please make sure you hit the like button, stay subscribed. Also, if you have any more doubts or if you have any more inquiries that you want to ask me, then leave it on the comment section down below. Until next time, take care. See you all.